Welcome to today's lesson on calculating kinetic energy. Today, we will firstly develop an intuitive understanding of how kinetic energy is related to the mass and speed of an object. We will then dive into the kinetic energy formula and understand the involved quantities and their units. Finally, we will apply the kinetic energy formula to various real-life scenarios. So far, we've discussed what kinetic energy is, a type of energy that an object possesses due to its motion, and how it plays a role in various physical situations. Building on this foundation, we can now introduce the kinetic energy formula and use it to calculate kinetic energy in practical scenarios. This understanding will enhance your grasp of physical processes and energy transformations. Imagine you have two shopping carts in front of you at the grocery store. One cart is empty and the other is filled with heavy items. When you push the cart, you're transferring energy to it through your effort. This energy doesn't disappear, it gets converted into kinetic energy, which is the energy of motion. If you try to push the empty cart, you will notice that it requires some effort. However, if you want to push it even faster, you'll need to exert even more energy. This energy that you exert is transferred to the cart as kinetic energy, and the faster you want the cart to go, the more energy you need to supply. This shows that the faster an object moves, the more kinetic energy it has. Now consider the filled shopping cart. Pushing this heavy cart to the same speed as the empty cart requires significantly more effort. If an object has more mass, it requires more energy to reach the same speed as a lighter object. This illustrates that a heavier object has more kinetic energy for the same speed. From this example, we can see two important points about kinetic energy. Firstly, faster speed equals more kinetic energy. This means that the faster you want the cart to go, the more energy you need to supply. Secondly, more mass equals more kinetic energy. So, the heavier the cart, the more energy you need to push it to the same speed. From these observations, we expect a mathematical relationship where kinetic energy increases with both speed and mass. But it's important to note that if the cart isn't moving at all, so if it has velocity of 0, it doesn't matter how much mass it has, its kinetic energy will still be 0. The formula for calculating kinetic energy is given by kinetic energy equals half mass times speed squared. This formula aligns with our intuitive understanding. As mass increases, kinetic energy increases. Similarly, as speed increases, kinetic energy increases, but since speed is squared in the formula, kinetic energy increases rapidly with increases in speed. Now, let's look at the variables in the kinetic energy formula. First, the mass of the object, which is measured in kilograms. Second, the speed of the object measured in meters per second. And third, kinetic energy, which is measured in joules. 1 joule is equivalent to the energy transferred when a force of 1 Newton is applied over a distance of 1 meter. This definition may feel odd now, but it will be clearer once we get to the concept of work done. To illustrate how to calculate kinetic energy, let's apply what we've learned to a few problems to consolidate our new knowledge. Our first example for today is calculate the kinetic energy of a ball with a mass of 2 kilograms moving at a speed of 3 meters per second. Our first step is to identify the given quantities. We have a mass of 2 kilograms and speed of 3 meters per second. Next, we need to use the kinetic energy formula. We know from earlier in this lesson that this is EK equals half mass times speed squared. Our third step is to plug the values from the question into the formula. So we get kinetic energy equals half times 2 kilograms times 3 meters per second squared. Next, we calculate the speed squared, which is 9 meters squared per second squared. Our final step is to multiply the values, which gives us 9. Don't forget the units. Kinetic energy is measured in joules. So, the kinetic energy of the ball is 9 joules. Let's look at another example. Calculate the kinetic energy of a car with a mass of 1,500 kilograms, moving at a speed of 20 meters per second. First, identify the given quantities. The car has a mass of 1,500 kilograms and speed of 20 meters per second. Then write out the kinetic energy formula. Next, plug in the values that we identified in step 1 into the formula. Then we can calculate the speed squared, which is 400 meters squared per second squared. Finally, multiply the values, which gives us an answer of 300,000 joules. So the kinetic energy of the car is 300,000 joules. Let's look at an example where we need to rearrange the formula. A bike and rider have a kinetic energy of 4,000 joules and are moving at a speed of 10 meters per second. What is the combined mass of the bike and rider? First, identify the given quantities. The kinetic energy is 4,000 joules and the speed is 10 meters per second. Then write out the kinetic energy formula like this. Since we want to find the mass of the bike and the rider, we need to rearrange the formula to solve for mass. To do this, first multiply both sides of the equation by 2 to eliminate the 0.5 on the right-hand side. Then we can make mass the subject of the formula like this. So we get mass equals 2 times EK divided by speed squared. Now we can plug in the values from the question to get mass equals 2 times 4,000 joules divided by 10 meters per second squared. We can now calculate the mass, getting an answer of 80 kilograms. So the combined mass of the bike and rider is 80 kilograms. Let's look at one final question. A ball with a mass of 2 kilograms has a kinetic energy of 200 joules. What is the speed of the ball? First, identify the given quantities. The mass is 2 kilograms and the kinetic energy is 200 joules. Then, use the kinetic energy formula, which we can rearrange to solve for speed. So we get speed equals the square root of 2ek divided by mass. Now we can use this rearranged formula to find the speed of the ball. Input the values from the question into the rearranged formula. Then we can solve for speed. So the speed of the ball is approximately 14.14 meters per second. Note that we only get an approximate answer for the speed in this example because the square root of 200 is an irrational number, which means that its decimal form goes on infinitely, never recurring or terminating. By working through these examples, you can see that calculating kinetic energy involves understanding and properly using the formula. This method can be applied to various objects in motion to find out their kinetic energy, mass, or speed. Let's recap. In today's lesson, we delved into the concept of kinetic energy, focusing on its formula and the quantities involved. We recapped the definition of kinetic energy from our previous lesson, and then discussed intuitions about kinetic energy using the example of pushing a shopping cart. We learned that kinetic energy can be calculated using the formula kinetic energy equals half mass times speed squared, and that it's measured in joules. We further discussed the significance of each term in the formula and how changes in mass or speed affect the kinetic energy. To reinforce our understanding, we worked through several examples of calculating the kinetic energy of a moving object. Overall, today's lesson provided a solid understanding of kinetic energy and its calculation, equipping us with knowledge essential for analysing various physical phenomena.
Watch the rest of the GCSE physics course at Sophos Education.